Hello there, and welcome to this collection of notebooks and tutorials on machine learning for audio signals in Python. This is a course offered by Professor Schula at the UMNL University of Technology. I am Renato, the instructor for these online materials, and on this tutorial we will talk about variational autoencoders. So the denoising autoencoder that we saw last time was robust against noise at its input. It was the audio signal. This time, the variational autoencoder is robust against noise in its encoded domain, what is also called the latent representation in the latent space. Here you can find a very nice tutorial about what is a variational autoencoder. There are very interesting explanations, and also here at this link you also find another very interesting tutorial understanding variational autoencoders. Similar to the denoising autoencoder, we also add a fixed noise during the training process, but instead to introduce noise at the input, we add it to the encoded signal in the latent space. But the training could just find a solution where the latent representation just becomes very big, which would effectively drown out the noise because it would appear relatively smaller. To counteract this, we introduce a regularizer term, which is added to the reconstruction loss function, usually the mean squared error. This is an added term for the loss function, usually with a factor for weighting the importance of the regularizer. This regularizer term is minimized if the mean value, meaning the output of our original autoencoder, is minimized. This punishes large values in the encoded domain and keeps the small in the training. We could now just train this network in this way, but to help the training, there is a parallel network which outputs the variance of the added noise for each element of the encoded signal in the latent space. In this way, the training can start with very little noise to help the training find a useful and suitable representation. To avoid the system staying in the no-noise state, there is an additional component in the regularizing term, which is minimized if the added noise has unit variance, meaning a variance of value 1 for each component of the encoded latent representation. This effectively punishes too little or too much noise. Too little more than too much. Hence, for this regularizer term, we need a measure for how different the current noise distribution is from the desired Gaussian noise distribution with zero mean and unit variance.